Exploring the stars has long been a dream for humanity, a dream that has persisted through centuries, from the earliest astronomers to the modern scientists pushing the boundaries of what's possible. The concept of interstellar travel, once purely the realm of science fiction, is increasingly entering the sphere of possibility thanks to rapid advancements in technology. At the forefront of these advancements are artificial intelligence, AI, bioengineered ships enhanced with nanotechnology, and nuclear fusion propulsion. Today's episode delves into how these cutting-edge technologies could make the once impossible journey to the stars a reality. As we embark on this exploration, AI's role in interstellar travel is multifaceted, acting as the brain behind operations, navigation, and problem-solving. With the vast distances involved in interstellar travel, traditional human-led spacecraft operation is impractical due to the immense time delays in communication with Earth. AI can autonomously manage spacecraft systems, adapt to unforeseen challenges, and make real-time decisions without waiting for instructions from Earth. Advanced AI algorithms can optimize flight paths, manage energy resources, and even conduct scientific research autonomously. For example, AI could analyze data from onboard sensors to navigate through interstellar medium, avoiding hazards and identifying points of interest. Furthermore, AI-driven robots could perform maintenance and repairs on the spacecraft, a crucial capability given the long durations and harsh conditions of interstellar journeys. Moreover, bioengineered ships represent a revolutionary approach to spacecraft design, integrating living systems with mechanical and electronic systems. These ships, enhanced with nanotechnology, could self-repair, adapt to different environments, and provide life support for human crews over decades or even centuries. Nanotechnology, manipulating matter at an atomic or molecular scale, could enable the construction of materials that heal themselves, adjust their properties in response to environmental changes, or efficiently convert solar energy into usable power. The integration of biological components can also contribute to sustainability within the spacecraft. For instance, bioengineered systems could recycle waste products, produce oxygen, and even generate food, creating a self-sustaining ecosystem that supports long-term human presence. These capabilities are essential for interstellar missions, where resupply from Earth is impossible. Additionally, nuclear fusion propulsion could provide the immense thrust and efficiency required for interstellar travel. Unlike chemical rockets, which are limited by their propellant's energy density, fusion propulsion harnesses the power of nuclear fusion, the same process that powers the Sun. This could theoretically allow spacecraft to reach speeds significantly higher than what is currently possible, shortening the travel time to neighboring star systems from millennia to mere decades. Fusion propulsion would work by using a small amount of fusion fuel, such as deuterium and tritium, to create a controlled fusion reaction. The energy released from this reaction would then be directed to produce thrust. Advances in magnetic confinement and inertial confinement fusion research are bringing this technology closer to reality, with AI playing a crucial role in controlling the complex conditions needed for stable fusion reactions. In addition, the human body evolved in the Earth's gravity, and prolonged exposure to microgravity environments can lead to muscle atrophy, bone density loss, and other health issues. Biotechnology, particularly in the realm of genetically engineered solutions and nanomedicine, offers innovative ways to combat these effects. For instance, gene therapy could be used to enhance muscle and bone strength, reducing the deterioration caused by microgravity. Similarly, nanobots, tiny robots that operate at a cellular level, could monitor and repair bodily damage, ensuring that astronauts remain healthy throughout their journey. Within these living ships, dedicated areas could be transformed into bioregenerative systems, essentially spacefaring greenhouses, where genetically modified plants and algae are cultivated to provide a continuous supply of fresh food for the crew. These organisms could be engineered to thrive in the unique conditions of space, producing high yields of nutritious fruits, vegetables, and perhaps even protein sources under minimal gravity and artificial light. AI systems can continuously monitor environmental variables such as temperature, humidity, CO2 levels, and light intensity, adjusting them in real time to create optimal growing conditions for each type of plant or algae. These smart systems can also predict harvest times, manage nutrient delivery systems, and even identify and respond to signs of disease or stress in the plants, ensuring that the crew has a steady and varied supply of fresh food throughout their journey. Moreover, AI can assist in the research and development phase of these bioregenerative systems, using simulations to predict how different organisms will perform in the unique conditions of space. By analyzing data from these simulations, AI can help scientists select the best candidates for space cultivation, engineer new varieties of plants specifically designed for space travel, and develop innovative farming techniques that are both resource efficient and space compatible. AI is not just a tool for navigation and decision-making, it is also essential in integrating the various technologies that make interstellar travel feasible. AI algorithms can optimize the design and operation of bioengineered ships, ensuring that biological and mechanical systems work in harmony. In nuclear fusion propulsion, AI can manage the intricate balance of conditions necessary for fusion reactions, adjusting parameters in real time to maintain efficiency and safety. Moreover, AI can assist in the development of these technologies by accelerating research and development. Through simulations and predictive modeling, AI can explore a vast array of designs and configurations for bioengineered systems and fusion reactors, identifying the most promising approaches without the need for costly and time-consuming physical experiments. While the technological aspects of interstellar travel are profoundly challenging, they are matched by equally significant ethical and practical considerations. The role of AI in particular raises questions about autonomy and control. Ensuring that AI systems operate within safe and ethical boundaries is crucial, especially when human lives are at stake in the unforgiving environment of space. The sustainability of bioengineered ships also presents a complex ethical landscape. Manipulating biological systems for space travel necessitates careful consideration of the implications for the ecosystems involved, both within the spacecraft and in potential extraterrestrial environments. As we conclude this journey, we're reminded that the universe is not just a place to explore, it's a canvas for our imagination. The fusion of AI, bioengineering, nanotechnology, and nuclear fusion is more than the sum of its parts. It's a testament to human curiosity and our relentless pursuit of knowledge. The challenges of space travel are immense, but so are the opportunities for growth, discovery, and innovation. As we stand at the threshold of a new era in exploration, we're not just looking outwards to the stars. We're also looking inwards, asking ourselves what it means to be human, and how we can build a better future, not just for ourselves, but for all life on Earth. From the first wheel to the first step on the moon, our journey has been defined by overcoming the impossible. Today, as we envision ships that heal themselves, engines powered by the stars, and technology that blurs the line between the biological and the mechanical, we're not just dreaming of new worlds, we're reimagining our own. The future is not a distant dream, it's a shared vision that we create together. Join the conversation, share your ideas, and be a part of this incredible journey. Subscribe to Paradox Chronicles, hit the like button if you believe in this vision, and share this video to inspire others to dream big. What role will you play in humanity's next chapter? Remember that every great journey begins with a single step. Together, let's take that step, fueled by curiosity, guided by intelligence, and united in our quest to explore the infinite wonders of the universe. Thank you for joining us on this extraordinary adventure. Stay curious, stay inspired, and keep pushing the boundaries of what's possible. Until next time, keep looking up, because the future is ours to explore.